Hey, what's up, everybody? I'm WCI3 Chief Meteorologist Kevin Lighty, coming to you from my home office studio. And we're doing something a little different here today, and for the kids. We had a lot of kids that obviously are at home from school, and they've been sitting around, or maybe wanting to talk a little education. And so we figured, what not a better thing to do than to ask for you guys and your kids to submit questions when it comes to the weather. And so many of you have posted your questions, and we're here just to answer those. So if you've got kids that are around and want to learn a little bit more about the weather, we're going to do that here right now, and we're just going to go ahead and get things started. All right, here we go. Let's do question number one. And this is actually going to come to us from Bailey, a first grader at the Land Weldon schools. And basically, Bailey wanted to know about different cloud types. And this graphic here shows some of those different cloud types and what they are. So basically, we've got different clouds that range from low-level clouds, like what we consider to be stratus clouds, all the way up to some of my favorite that are known as cumulonimbus clouds, and those are the ones that produce thunderstorms. And so we've got all these different types of clouds. And so again, the question that Bailey wanted to know about was, what are the different types of clouds, and how do they form? And so those clouds that you see there, they can grow really tall. So the cumulonimbus clouds go up to 50,000 feet. And those are the ones, again, that are producing sometimes your severe weather. They're the big, huge, tall, dark clouds a lot of times. But similar to those are ones that are what we call the fair weather cumulus clouds. And so clouds there that are the nice ones on a nice sunny day, that you've got those out there. And then you've got, as you go up, alto, which means basically middle clouds there for stratus and cumulus. And then you go really way up high, and you've got cirrus clouds, and those are up to 18,000 feet. And so those clouds there are really kind of thin and wispy. And they are made up of tiny little ice crystals that are, there's millions of tiny little water particles that basically make those up. So, how clouds form. So it's actually a basic kind of principle that has to do with the water cycle. Okay, some of you may have learned about the water cycle in school. And so what you've got is the sun that's out there all the time. Okay, it heats up things like the ocean. Okay, and you get evaporation that takes place. So the little water particles, they evaporate and they go up into the air. And then a formation or a process called condensation takes place, which turns those little water particles into clouds. Because again, those clouds are made up of just millions of tiny little water kind of little particles there. And then eventually, too much of that water particle in the clouds falls back down to earth as rain, and then the cycle just continues over and over again. So Bailey from the DeLand Weldon Elementary School, that's a little bit about clouds. All right, let me move on to my next one here. And I believe this one is, sorry, I'm having to go back and kind of look at the questions, but I believe this one has to do with, what is my favorite type of weather instrument? Okay, so this one coming to us from Noah. Noah from Edison Elementary. And yes, Noah wants to know, what is my favorite type of weather instrument to use and why? Well, that's pretty easy for me. I love Doppler radar. Okay, so Doppler radar is something that we use all the time to try to see what storms are doing. Okay, and so the Doppler radar is always out there and scanning the sky looking for storms. And so it actually looks like what it looks like on that left side of your screen, almost looks like a big golf ball sitting on top of a tower. Um, if you had little black parts to that, it would almost look like a soccer ball. But it is got a little antenna inside and it's spinning around and it's going out and it's looking for any kind of clouds or rain, precipitation, and looking at the wind speed and then telling us a lot about what's going on. Now, the graphic that's on the right shows all of the Doppler radar sites that are distributed across the United States. And all of those Doppler radars that we use come in handy to give us information like this. That Doppler radar goes out, and then we display it on the radar in all these different colors. And then that allows us to see rainfall, if there's hail, if there are bad storms like tornadoes in there. And so then it allows us to warn the public, to be able to tell you guys, tell your parents, hey, you need to take shelter, go to your safe place. And I'm sure many of you have practiced and kind of know where to go, whether you've done it at school or at home. But a Doppler radar allows us to actually be able to see those bad storms before they get to you. So it's a great technology. And so that's probably one of my favorite weather instruments that I'm able to use on a daily basis to be able to tell the weather. All right. Thank you, Noah, for your question. All right. Next up, we have Olivia, 4th grade, Bismarck Henning Elementary, wants to know, how does a tornado form and why does it just disappear into the air? Well, tornadoes are really complicated on how they form. There's a lot that goes into it. I kind of liken it to baking a cake or baking cookies. You've got to have all of the right ingredients to form a tornado. You've got to have the right amount of sugar, the right amount of flour, and the right amount of, well, other things. Obviously, I don't bake that often, but you get what I'm talking about. You have to have all of those things correct, or it will come out wrong. So basically, if I baked something, it'd probably come out wrong. The same thing happens when trying to get a tornado to form. You have to have all the perfect ingredients. They're rare. They don't happen very often. Okay, so but all the right things have to come together. This is a little bit of a diagram that shows the big, huge picture of a thunderstorm and one that may include a tornado. If you look at the bottom, down there, in kind of the middle of your screen where it says wall cloud, and then you can see the little funnel that dips down from there, that's basically kind of what it looks like. And so you've got Tornado Alley. You've got an area out in Oklahoma and Kansas and Texas, Nebraska. That's kind of the prime area. But this happens because of warm, moist air that streams in from the Gulf of Mexico. You've got cold, dry air that comes in from the north, streaming across Canada. Canada is a big landmass out there, and so you get this this cold air, dry air, and when they come together over the plains, a lot of times that will spawn bad storms and sometimes tornadoes. Now, there are 4 ingredients you really need. You need instability, you need lift, you need moisture, and you need wind shear. And wind shear is kind of what we're going to talk about. So what's happening is when there's wind shear is basically when the winds are changing as you go up in height in both speed and direction. So you may have winds going like this here where we all stand on the ground. But if you go up higher, the winds will change direction. Even higher up you go to like where airplanes fly, they'll be going in a whole nother direction. So you're getting this twisting motion. But before we even get to that, on the ground, there's already this rolling column of air. Okay, so that's the top part of your graphic there. So it's rolling along and kind of spinning. And what happens is when a thunderstorm gets going, it's got what's called an updraft. And sometimes that updraft can tilt that horizontal spinning column vertical. And so then you get a tornado that forms. So again, there's a lot of processes that are happening to make it. But yes, the old adage of, well, isn't it just cold air and warm air come together? Well, that's a very basic principle of that, yes, I would say. But obviously there is a lot of things going into that. Okay, let's move along. Good question, Olivia. All right, next up, let's see what we got. I believe we have Sophie. Let me pull it up here. Sophie, where are you at, Sophie? Or did I skip one here? Well, let's go to it. Oh, yes, Sophie was wanting to know about earthquakes. She's from Bement Elementary, from Bement. Sophie asks, can earthquakes happen in Illinois? And what's the strongest ever recorded? Earthquakes can happen in Illinois. A lot of times they're a lot smaller than they are across the U.S. Now, what you're looking at here, I've got two graphics up here. One is on the left, and that is one of the strongest earthquakes to strike even the much of the United States, and especially the Midwest. It was called the New Madrid earthquake down in New Madrid, Missouri, kind of down in the Boot Heel. But you can see how close it is to Illinois, Kentucky, Tennessee. All of those states were impacted by this huge earthquake that happened around 1811, 1812. That was a big one there. But the impacts could be felt further into Illinois. Now, the one that is the strongest for Illinois was actually a one that was down in far southeastern Illinois. You kind of see the little red area there that I've got to highlighted. It was a 5.3 on what is known as the Richter scale. Now, the Richter scale basically measures how strong an earthquake is, and that one was about a 5. So it was not terribly strong. We don't get really strong earthquakes here in Illinois, but boy, do they get them in places like California, where they can go 8 or higher, and they can do a lot of damage. All right, so good question there from Sophie. All right, moving along. We have Janie, first grader, North School Elementary in Taylorville. Why can I smell rain coming? I really like this question. Have any of you been outside before and you've been able to you could tell there's something in the air and you'd be able to smell, even you adults kind of may know what I'm talking about. A lot of farmers, they'll tell you, "Oh, I can tell you when it's about to rain," and that's because there is a true reason for this. And it actually has to do with the compounds of what's on the ground and the dirt and some of the plants there. They actually start to give off an aroma. There's actually little tiny bacteria, and there's these plant oils, and when there's just a little bit of moisture that starts to fall on top of the dry ground, you're going to get basically this smell that starts to come up. It basically just comes right from the ground, from the dirt, from all of that, and you can smell it. Gives off this interesting smell. And what happens is the wind will carry that smell. So it may not be raining where you're at yet, but the wind will come along and it will blow that smell, because it's almost like a little aerosol. You spray it in the air and those particles get in the air, and the winds will blow that further, usually because the winds are basically blowing towards where the storm may be going. So you're going to get this smell that occurs, and it's a very interesting thing that actually is a true thing. Your nose can detect it, and it's very cool. And the aroma of rain actually has a name to it. The smell of rain, and I'm always bad about even trying to pronounce it, but it's called. Let me see. I can spell it for you. Petrichor. Petrichor. Petrichor is what it is. And so that is the unique smell that you will get when a thunderstorm or rain is about to move in. That is a good question. I really like that one a lot. All right. Moving along. Why does it rain as well? This is from Adeline, first grade at Villa Grove. So again, this kind of goes back to kind of towards the beginning, where we talked about the sun coming in, heating things up. That air rises, it condenses, and you get clouds to form, and then the rain falls. And this cycle just keeps going on and on and on and on every single day across the globe. It never stops. Again, sun heats up that air. or heats up kind of the water there in the air, and the air rises because warm air likes to rise, and then condensation, and then the rain falls from the clouds when basically almost the clouds get too heavy, and then you get that rain to fall all the way down. So there you go, Adeline. All right, let's see what we have up next. Emma. Oh, wanted to know, why did I become a meteorologist? Well, I have been interested in weather ever since I was a little kid. Always wanted to know more about how the stuff worked. So the picture that's up on their left-hand screen is actually me. I think I was like 13 or 14 years old. I used to take a video camera outside and tape myself as if I was like on the Weather Channel or something like that. So I would go out there and do that. And then of course I got my job. I started in Terre Haute, Indiana, and I worked some in Kentucky and some in Indianapolis, a lot of time down in Springfield, Missouri. But I just have loved the weather ever since I was little. I always wanted to know more about it. So I decided to go into it, and I have not made a mistake. I definitely did not make a mistake by doing that, because it has been so much fun doing this over my almost 18 years now of doing this. So, Emma, if you would like to do that someday too, I encourage you to follow your passion. Okay, next up, we've got Avery, first grade at Villa Grove, wanting to know about where does lightning come from, and is it always white or yellow? So lightning comes from the clouds. Basically, what happens is you get a buildup of static electricity. Um, if you've ever been shocked before, it's a buildup of static electricity that occurs. And what happens is up in the cloud, in the bottom part of the cloud is charged what we call negatively. If you've ever had magnets before, magnets come together, so they've got different polarities. So there's positive and kind of negative, and so they'll come together. Kind of a similar thing happens with lightning. Objects on the ground, like trees, are positively charged. So you start to get this kind of creeping towards one another. And when those connect, you get the lightning bolts that will occur. And so you've got the negative charges in the cloud, the positive charges on the ground, and boom, they connect to one another. And then you get the lightning bolts that will occur. A lot of times, the lightning it's electricity, it's white, but depending upon kind of some of the chemicals in the sky and some of the current conditions, it can look purple, it can look yellow. I mean, it can look a lot of different colors. So it's not always that. I've seen lots and lots of pictures of purple lightning, which I think is some of the most beautiful to photograph. So there you go there. All right, good question from Avery in Villa Grove. All right. Next up is Ava. Where does the sun hide at night? Ava from Shiloh Elementary Preschool. So the sun, it's really kind of cool. The sun kind of hides from us, as you put it, because our Earth is actually spinning. It is basically spinning on its axis, and it does that once every 24 hours. Now, we're also going around the sun. Okay, we're orbiting the sun. Now, the sun doesn't move. The sun stays here, and our Earth is going around the sun, but that's what causes the seasons. Our Earth is spinning on its axis. So every 24 hours, it goes around once, like a merry-go-round. Goes around once, okay? So think about this. If you're on a merry-go-round, okay, and let's say let's say your mom or dad, they're shining a flashlight at you on one side of the merry-go-round, okay? So as you're at this point on the merry-go-round, the sun's going to be right on you. But as you go around, okay, to the other side, the sun won't be hitting you. You'll be on kind of the dark side, okay? And that's nighttime. But as we continue to spin on our axis, we'll come back around, and we'll be there at where the sun or the flashlight is hitting you once again. So the sun just sun doesn't really go anywhere. The Earth is what's going somewhere. We're spinning on our axis once every 24 hours. Ava from Shiloh Preschool. Next up is Eli, kindergarten at Villa Grove. wants to know about why is it always so windy? What makes the wind? We get a lot of wind here in central Illinois, that's for sure. So our wind here, it actually has to do with the differences in air pressure and kind of the uneven heating of the surface of the earth that causes these different pressures of the air. And so you've got high pressure, you've got low pressure, and depending upon the placement of where these are across the United States or the world, it determines wind flow because wind flows between these high and low pressures. And so it's kind of a difficult concept to explain, but essentially, when you get a really strong area of high pressure or low pressure, you'll get these really, really kind of strong winds that will occur, especially when what we call isobars are tightly packed to one another, and they will squeeze the winds and make the winds go into little tunnels that kind of force them through, and they go a lot faster. Here in central Illinois, we get so much wind, it's really flat out here. There's not a lot that stops the wind from blowing. So that wind just kind of blows across a lot of the area here in the prairies and the fields, and we just get a lot of wind, which is why there's so many wind turbines that we've got across the area and wind farms that are here. So yeah, a lot of wind. All right, next up, Kelby, third grader. Oakwood wants to know about tornado speeds. What's the fastest that tornado speeds can go? Well, we actually use something called the Enhanced Fujita Scale. Scale actually rates tornadoes from 0 to 5, and it's based upon the winds there. So a lot of times we only get winds that are like 65 to 85 miles an hour. These are really weak kind of tornadoes. 65 to 85 mile an hour winds. Then it goes up to EF1, 86 to 110 mile an hour winds. You go all the way up, and EF5 is 201 mile an hour plus. Now, it has been known that some tornadoes will go as high as 300 miles an hour. Some have actually recorded that speed with what's called a DOW, a Doppler on wheels. They actually took out a portable Doppler radar and actually recorded that in a storm out in, I believe it was Oklahoma. So really, really fast winds. We don't typically get those here. We get the smaller tornadoes here in central Illinois most of the time. All right, good question there from Kelby. Okay, Avery, again, we get another Avery. Third grader, Samalakai Rentoul wants to talk about how can I tell how far away a storm is or a lightning strike was. Well, this is actually kind of cool. You can tell how far away lightning is by watching for the lightning bolt. Now do this obviously from inside your home where it's safe. Maybe you see the flash out your window. And then you can count 5 seconds, okay, count up to 5 seconds for every mile away until you hear the thunder. So basically, lightning bolt occurs, start counting 1, 2, 3, 4, 5. If you get to 5 and you haven't heard the thunder yet, that means it was at least 1 mile away. Now, if you do some simple math, if you count to 10 seconds, that's 2 miles. 15 seconds, 3 miles away. If you count 30 seconds between when you see the lightning and you hear the thunder, that lightning bolt was 6 miles away from you. Here's the thing. You never want to count 0 seconds between the lightning and the thunder, because that means that lightning was almost right on top of you. So that's a lot of times you can get some of the really, really loud thunder and the lightning when they happen really close to one another. Okay, so there you go. Okay, all right, I have one more question here. So we're not going to be able to go through all of them, but we got quite a few. We appreciate everybody who did submit their questions, and if you guys wind up liking what we've done here, then we will do more of these here, possibly here in the future. But our final question comes from another Avery. It's our third Avery from 4th grade Oakwood, and wants to know about thunder. Thunder. So I'm going to come back on camera here real quick. And all right, because we're going to do a little experiment here with those of you kids that are left. So How does thunder form is what Avery was wanting to know about. So essentially, thunder is nothing but kind of the air crashing into itself. So, in a very basic sort of physics, when something heats up, it expands. And when something cools down, it retracts. So, kind of follow along with me here, okay? Lightning, I'm going to tell you this. We didn't get into this specifically, but lightning is really, really hot. It's 50,000 degrees Fahrenheit. Really hot, okay? So, everybody out there, put your hands together like this. Just put them together, okay? All right, there we go. Everybody got their hands together? Hands together like that? Okay. So our hands are essentially the air, okay? So the air is just kind of right here. And what happens is, and I'm just going to use this because it's in front of me, and why not? But they're Reese's cups. That's what I've got in front of me. Are you hungry now? Reese's cup is a lightning bolt, and it comes streaking down through the sky. Okay, here it comes. And then it disappears. But as it goes through the air, that air expands. So take your hands that are like this, and now go like this, because now the air is expanding, okay, as that huge lightning bolt that's really, really hot just heated up the air to 50,000 degrees Fahrenheit. The air expanded, but that lightning bolt only lasts a few milliseconds, and then it's gone. So suddenly that air is going to cool down. So what happens? It comes crashing back into itself, and you get the sound of thunder. So here we go. We're going to take our hands. The lightning bolt comes through. The Reese's cup comes through, expands the air like this, but it cools it down quick, and boom, you get the loud clap of thunder. That is all that thunder really is the air that is crashing into itself there because the lightning bolt heating up the air and the air cooling back down once again. So, good question there from our third Avery from Oakwood. All right, guys, that's going to wrap up our little Weather 101 lesson. I hope you guys enjoyed this. Hope the kids enjoyed this, parents as well. A little weather lesson for many of you, and hopefully you got a little something out of this. And if you've got some others that maybe didn't get the chance to see this, it's going to be here on our Facebook page, so you can share it to others. Go back and watch it later if maybe one of your other kids wasn't there, they're out playing or something. But this will be here. If you guys like these, well, we'll do more of these little weather education little live streams for you guys to kind of help the parents out a little bit as well, and do a little education here in this time that we're in. So I want to thank everybody for tuning in again. Again, I'm coming to you here from kind of my home office as I kind of work from home here this week. And I just want you all know that keep tuning back into WCIA. We'll continue to keep you up to date with everything that's going on. And we will maybe do another one of these again. All right, guys, have a good one. Stay safe out there. Always stay weather aware. And like I always like to say, you know what? Always keep an eye to the sky. See you guys.